So welcome to this class. In this session, we are going to discuss about dot product, our dot or scalar product. So let's start by defining what we mean by dot product. So definition. So let A and B be vectors. The dot product, the dot or scalar product of vectors A and B denoted by is given by I dot B is magnitude of vector A times magnitude of vector B multiplied by cosine of the angle between these vectors A and B. And this angle is between 0 and 180 degrees. So this is the definition of dot product. And then one thing that you have to note is that dot product is defined for two vectors, but the result is a scalar quantity. So note dot product is a scalar quantity. Remember, a scalar is a quantity that has only magnitude, but no direction. So laws or properties of dot product. So given that A and B are two vectors, given that A and B are two vectors, and M is a scalar, then so one, A dot B is given by B dot A. So this to tell us that the scalar or the dot product obeys commutative law. So this is the commutative law for dot product. So that's one. Number two, so we have A, B, and C, the source of vector C. So number two, A dot B plus C is the same as A dot B plus A dot C. So this means the associative property for distributive property for dot product. Distributive property. And then number three, if I have M, I multiply by the dot product of A and B, I get the same result for saying M multiplied by A first, and then I dot the result with vector B, or I take vector A, I dot with the scalar M multiplied by vector B, and the same thing as taking A dot with B, and then finally multiply by M. And then number four, I dot I is equals to J dot J is equals to K dot K, and the answer is 1. So because remember we said dot product of two vectors A and B is magnitude of A times magnitude of B, and then cosine of the angle between the A and B. So for this I, J, K vectors, remember this is the X, Y, Z axis. So usually this is the K, this is the I, this is the J. So this is the X, Y, Z, K, and then J. So the angle between, so if you are to find I dot I, the magnitude of I times magnitude of I, cos of the angle between I and I is 0. So cos 0 is 1, so 1 times 1 times 1 is 1. Similarly, J, the angle between J and J is 0. So cos of 0, 1. So magnitude of J, 1, magnitude of J, 1. So J dot J is 1. Similarly, K dot K is 1. But then if I say I dot J, then I'll have to get the magnitude of I. So I dot J will be given by magnitude of I times magnitude of J times cos of I and J. So angle between I and J is 90 degrees. And because cos of 90 degrees is 0, so I dot J is 0. Similarly, J dot I is 0. And then J dot K is the same as K dot J. And the answer is still 0 because J and K, the angle between them is 90 degrees. So cos of 90 is 0. And similarly, I dot K equals to K dot I, which is also 0. So this definition will help us to also get another formula for dot product. Once you know that I dot I equals to J dot J equals to K dot K equals to 1, and these other combinations give you 0. Number 5, if I have vector A given by A1I plus A2J plus A3K, and B is given by B1I plus B2J plus B3K, then A dot B is given by A1 B1 plus A2 B2 plus A3 B3. And you can quickly prove this from the result we got in 4. So proof. So A dot B, we have been given A is A1I plus A2J plus A3K dot B1I plus B2J plus B3K. So which will be given by, I take A1, I dot with all these vector. So B1, I plus B2J plus B3K plus I take A2J, I dot with B1I, B2J, B3K. Plus I take A3K, I dot with vector B1I, B2J, B3K. And then so A dot B will be now, let's open here. So remember A1 is a number, B1 is a number. So the thing you just have A1, B1, and then I dotted with I, plus A1 is a number, B2 is a number, then I dotted with J, plus A1 times B3, and then I dotted with K. So that's expansion of the first term. Second, I'll have plus A2 B1 J dot I plus A2 B2 J dot J plus A2 B3 J dot K. And then plus, here we have A3 B1 K dot I plus A3 B2 K dot J plus A3 B3 K dot K. And then from the result we obtained in 4, you see clearly that this is 1, this is also 1, this is also 1. But the dot product of different unit vectors will give us 0. So this will be 0, 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 and then this will be 0. So therefore, that reduces the result of A dot B to simply A dot B equals to, now we'll just have this term, and this term, because this one goes to 0, goes to 0, goes to 0, goes to 0, goes to 0. Similarly, this one goes to 0 because of the dot product of different unit vectors. So I have A1, B1 plus A2, B2 plus A3, B3. So this is the formula for, another formula for defining the dot product of two vectors A and B. So that's the result. So to know when to apply, either the formula with angle or the formula without the angle, depends on the question that you have. So if they give you the angle, then the formula with the angle becomes easier one to apply to get the answer. If they give you a problem where the vectors are just given without the angle, then the formula with these just components becomes the most appropriate one to apply. So let's do an example. So we have this. So example, given that I have vectors A and B with the values, A is 2I plus 4J plus 3K, and B is 3I minus J plus 2K. Find, so there are two questions, A dot B, are three questions, B dot A, and then 3 theta, angle between A and B. So this will be easily done by the formula without the angle to get A dot B. So note that A dot B is given by A1 B1 plus A2 B2 plus A3 B3. So it will be given by our A1 is 2, our AB1 is 3, our A2 is 4, our B2 is -1, our A3 is 3, our B3 is 2. So this will give us 6 plus -4 plus 6, which would be 12 minus 4, which is 8. So that's the first part. Second part, B dot A is B1 A1 plus B2 A2 plus B3 A3. B1 is 3, A1 is 2, B2 is -1, A2 is 4, B3 is 2, A3 is 3. So this will still give us 6 minus 4 plus 6, which is still 8. So we have the answer to part 1 and 2. Now to get part 3, you remember that A dot B is given by magnitude of B, magnitude of A times magnitude of B, then cos of the angle between the two vectors A and B. So this is so the first thing, let's get the magnitude of A. So magnitude of A is given by the square root of A1 squared plus A2 squared plus A3 squared, which is the square root of 2 squared plus 4 squared plus 3 squared. So magnitude of A will be the square root of, so 2 squared plus 4 squared plus 3 squared, that is 29. And magnitude of B is square root of B1 squared plus B2 squared plus B3 squared, which is the square root of now 3 squared plus minus 1 squared plus 2 squared. So we have 3 squared plus minus 1 squared plus 2 squared. That gives us 14. So this will be magnitude of B equals to root 14. And so we have the value of this, and this one here. So we can easily find cos theta. So cos theta from this formula will be A dot B divided by magnitude of A times magnitude of B. So our A dot B is 8, magnitude of A is root 29, magnitude of B is root 14. So this is cosine of theta. So it tells us that now we'll have square 8 divided by square root of 29, square root of 14. That is cos theta equals to 0.3970333333. So theta is the cos inverse of this answer, 0.3970333333. So which will be 66.60715165 degrees. So that's what we have. Another example. Find the angle between the vectors A, we have 2i plus 2j minus k, and B, we have 6i plus 3j plus 2k. So this is just application of the two formulas of dot product. So we say A dot B first is given by A1, B1, plus A2, B2 plus A3, B3. So remember this is our A1, so we have 2. B1 is 6. A2 is 2. B2 is 3. A3 is minus 1. This one here. B3 is 2. So this will be 12 plus 6 minus 2. This will give us 16. So that is A dot B. And then our next magnitude of A will be given by square root of 2 squared plus 2 squared plus minus 1 squared, which is the square root of 4 plus 4 plus 1, square root of 9, which is 3. Magnitude of B will be given by square root of 6 squared plus 3 squared plus 2 squared. So that's 6 plus 9 plus 4, square root of 49, which is 7. So we also know that A dot B is magnitude of A, magnitude of B, cos of angle between A and B. So which means we'll have cos of theta to be A dot B over magnitude of A times magnitude of B. So that cosine of theta, from our calculation, we have 16 over 3 times 7. And then 3 times 7 is 21. So cos theta, or theta will be now the cos inverse of 16 over 21. And this will give us 40.36759,354 degrees. So that would be the angle between those two values. For those are the angle between the two vectors. And then note this maybe should have been placed as one of the properties. If A dot B equals to 0 and both A and B are proper vectors. So this means not 0 or null vectors. Then A and B are orthogonal. So orthogonal means they are perpendicular, or the angle between the two vectors is 90 degrees. Are orthogonal. Orthogonal is the same as perpendicular. So when you get the dot product of two vectors which are not zero vectors, then those vectors must be orthogonal or perpendicular, or the angle between the two vectors is 90 degrees. So just as an example, I remember that result is obtained from definition of dot product A dot B being given by magnitude of A times magnitude of B, then cosine of the angle between the two vectors. So if you say that A is not zero, A is non-zero vector and B is non-zero vector, then what that one means is that magnitude of A is not zero and magnitude of B is also not zero. So for the product of three numbers to get zero, then it means that if this is not zero, this is not zero, then this must be zero. And cosine of 90 degrees is what gives us zero. So that's why you're saying that if A and B are not zero vectors, then the angle between the two vectors A and B is 90 degrees if the dot product is zero. So if A is given by 2i plus aj plus k, and B given by 4i minus 2j minus 2k are orthogonal or perpendicular, find the value of A. Find this color A. Now this is a very easy problem if you know the definition of orthogonal vectors from dot product point of view. So just say A is orthogonal to B implies that the dot product of A and B is zero. And we know that A dot B is given by A1 B1 plus A2 B2 plus A3 B3. So this should give us zero from definition. So this is the solution. A1 is 2, B1 is 4, A2 is A, B2 is minus 2, A3 is 1, B3 is minus 2. So this would give us 0. So 4 by 2 is 8. So minus 2A plus minus 2 equals to 0. So this now we are just reducing the problem to solving a linear equation in A. So this is the same as 8 minus 2A minus 2 equals to 0. So 8 minus 2 minus 2A equals to 0. 6 minus 2A equals to 0. This means 2A equals to 6, taking this to the right. And then to get A, divide through by 2. So divide by 2, divide by 2. So this and this. So this means A is given by 3. So therefore, the value of that constant is 3. So that's how we interpret dot product, and with the examples given, then you should be able to solve as many problems as possible on dot product. Thank you.